Liberty Bell Fitness Inc. operates a chain of fitness centers in Philadelphia. The firm's controller is accumulating data to be used in preparing its annual profit plan for the coming year. The cost behavior pattern of the firm's equipment maintenance costs must be determined. The accounting staff has suggested the use of an equation in the form of y equal to a plus bx for maintenance costs. Data regarding the maintenance hours and the costs for last year are as follows. So we have data for the last year, that is data regarding the machine maintenance hours, as well as the costs you have from January, December. That is hours of maintenance service and maintenance costs. So that's our data from January to December. You can peruse through. What are we required to do? Using the high-low method of cost estimation, estimate the behavior of the maintenance costs incurred by Liberty Bell Fitness Inc. Express the cost behavior pattern in the equation form. Using your answer to requirement 1, what is the variable component of the maintenance cost? Compute the predicted maintenance cost at 600 hours of activity. Compute the variable cost per hour and the fixed cost per hour at 610 hours of activity. Explain why the fixed cost per hour would be misleading. So Roman 1, you're using the high-low method of cost estimation. Estimate the behavior of maintenance costs incurred by Liberty Bell Fitness Inc. Express the cost behavior pattern in the equation form. The equation form is given up here, y equal to a plus b x. You should be knowing what y stands for, what a stands for, then b and x. Now the high-low method, it's a method we use in cost and management accounting to separate out fixed and variable costs. So in case we have a mixed cost, like in this case, we have maintenance costs. Maintenance costs in this case are likely to be mixed costs. So they want us to use the high-low method to separate these mixed costs, the maintenance costs. So we use it to separate out fixed and variable costs from a given mixed costs data set. When using the high-low method, of course, we take into account the highest activity level and the lowest level of activity and comparing the total cost at each level. However, when you try to look at the information given, let's try to see if we can come up with the highest level of activity and then what is our lowest level of activity and then the costs at each level. So hours of maintenance service, what is our highest level of activity or highest hours of maintenance service? What do we have? What do we have? Of course, we have a 500. We have 525 as our highest level of activity. And the cost we have at this level is 4,710. That's what we have. So we have the highest activity level and then the corresponding maintenance costs. Then of course we also have to get the lowest activity level. Where do we have the lowest? Of course, when you try to look at the lowest, now this one is a bit tricky because you have a 310 here, but of course the 310 does not give you the lowest maintenance costs. Now the lowest maintenance costs is 2,950, and the corresponding hours of maintenance services is 315. But 315 is not your lowest activity level. Your lowest activity level is 310. This is your lowest activity level. And the corresponding cost at that level is 2,910. 2,910. But this is the lowest here. The 2,950, you see it's the lowest maintenance cost. However, it does not, the hours of maintenance services still are not the lowest, though the cost is the lowest. So we see that the high or the low levels of cost do not match the high or low levels of activity. So what do we have to do? We have to choose the periods with the highest and the lowest levels of activity and their associated costs. So we have to look at the hours of maintenance service if you have to get the high and low points. So I'll not use the 315, I'll not use the 2950 because my highest activity level is 525 and the lowest is 310. So we use these with their corresponding maintenance costs. That's how we can use the high-low method, where the costs, the high and the low, do not match the levels of activity. So what we have to do is select the highest activity level and the lowest activity level with their corresponding costs. That's what we use. So I'll use 525 and then 310, then 4710, and then the 2,990 as my cost at the lowest activity. So what can we do now? We can compute the variable cost per unit. We can compute the variable cost per. We can compute our variable cost per unit. In this case, it will be variable cost per maintenance service hour. Variable cost per maintenance service hour. Maintenance service hour. How do we compute this? We get our total cost at highest minus total cost at the lowest level, then over the hours at the highest activity level minus the hours the lowest activity level. Therefore, our variable cost per maintenance service hour will equal to 4,710 minus 2,990 over 525 minus 310. So this will give us what? Let us see. 4,710 minus 2,990, that is 1,720. 1,720 1,720 divided by 215, is it? 525 minus 310, that is 215. Here we have $8 per hour. We have $8 per hour. So that is our variable cost per maintenance service hour. What was the requirement of the question? Let's try to look at the requirement of the question. Then you'll see. Express the cost behavior pattern in the equation what? In the equation form. Express the cost behavior pattern in the equation what? In the equation form. Express the cost behavior pattern. Cost behavior pattern. The equation form. Cost behavior pattern in the equation form. Now, when it comes to coming up with the cost behavior pattern in the equation form, here, of course, you can either use the highest activity level because we need to come up with our fixed costs. So we need to show the cost behavior pattern in the equation form. So we need to first calculate our fixed costs. So using the highest activity level, using the highest activity level, the total costs. We need to check the total cost at the highest activity level. We need to look at the total cost at the highest activity level. Let's try to check that out and see. That total cost is 525. Okay. So no, the total cost is 4,710. So total cost is 4,710. This is 4,710. This is 4,710. Okay, for 710. Then we have to get the variable costs, the variable maintenance costs. Variable maintenance costs. At the highest activity level. Highest activity level. Remember that level you had 525 hours. But each hour we have seen that it is $8. What is 525 times 8? 525 times 8. This is 4,200. So meaning that we can now get our fixed maintenance cost per month. Fixed maintenance costs per month, which is the difference between the total maintenance cost, then minus the fixed, minus the variable maintenance costs to get the fixed cost. So this is for 710 minus 4,200, giving us dollars 510. So this is our fixed maintenance, the fixed cost maintenance cost per month. The equation form, if you have expressed that in an equation form as per the question, the equation form they want is y equaling a plus b what? Plus bx. But remember, y represents the monthly maintenance costs. Y represents the monthly maintenance costs. So the equation form will be the monthly maintenance costs will equal to the fixed cost, which is 510 plus dollars 8 x. Okay, where x denotes hours, where x denotes hours of maintenance service. Where x denotes hours of maintenance, where x denotes hours of maintenance service. So that is the first part of the question. Let's look at Roman 2 of the question and see. Using your answer to requirement 1, what is the variable component of the maintenance costs? Of course, we have completed that. It is shillings 8. So just come here and say that the variable component, we are answering question 2. The variable so you want us to come up with a variable component. Variable component of the variable component of the maintenance costs. This is the $8 per hour. This is what we have computed. $8 per what? Per hour. $8 per hour of service. $8 per hour of service. Then the other part is to do what? Predicted maintenance cost at 600 hours of activity. You just need to substitute in the equation. So 3 this is predicted. Predicted maintenance costs at 600 hours of activity. So if you have to compute this, cost we say maintenance costs will equal to what? Will equal to our fixed cost, which we have as 510 plus the 600 hours, which is your x, times what? Times $8, our variable cost component per hour. This gives you how much? 600 times 8 plus 510. Excuse me. This gives us $5,310. Then Roman 4, what was Roman 4 all about? Compute the variable cost per hour and the fixed cost per hour at 610 hours of activity. Then explain why the fixed cost per hour would be misleading. The variable cost per hour and the fixed cost per hour at 610. Okay. This is Roman 4. Okay, number 4. They want us to come up with the variable cost per hour. Variable cost per hour at 610 what? At 610 hours of activity. Now, the variable cost per hour, of course, is the same. It is the same regardless of the hours of activity. So this is the same as in Roman 2. It is $8 per hour of service. So this is $80. Still the same. That is the variable cost per. That is the variable cost per hour. Still the same cost per hour. Then when it comes to the fixed cost per hour, we know that from our cost behaviors, the fixed cost per hour at 610 hours of activity. Of course, now this will equal to, we have our fixed costs already, which we have as 510. When I divide by 600 hours, this gives us what? Let's see. 510 divided by 600 hours. This gives us $0.85 per hour. That will be your fixed cost per hour at 610 hours of activity. The variable cost per hour will be $0.85 per hour. Remember, the fixed cost per hour will decrease as output increases. So it will keep on decreasing as your output is increasing. Why is this misleading? Of course, the fixed cost per hour is misleading. Is a misleading amount. A misleading amount because it will change. Because it will change as the number of hours change. Because it will change as the number of hours changes. The fixed cost per unit will decrease as your output is increasing. So it's not constant as the variable cost per hour. Let me just use a simple example. For example, okay, at 500 hours, okay, at 500 hours of maintenance service, maybe of maintenance service, the fixed cost per hour is what? Let us see. We have our 510 divided by 500. Let us see the fixed cost per hour at that level. This is 510 divided by 500. You see, it is now 1.02 per hour. So this is at 500 hours. So you see the fixed cost per unit per hour is a bit higher than when the hours are 600. So the fixed cost per hour will change as the number of hours changes. So that is why it is misleading. It will keep on changing as the number of hours change. So those are the 4 questions. We have seen how to use the HIRO method. Thank you for watching. Don't forget to subscribe. Bye bye.